Welcome to Carlton's Math Corner. Today, we're going to continue our study on the distance formula. At this time, please make sure you have your math journal, vocab packet, as well as something to write with. Today, our target is I can use the distance formula to find the missing coordinate between 2 points. Okay, so here's our situation. It says find the possible values for A if the distance between points at 4, 7, and A3 are 5 units apart. Okay, so let's make some observations. What do you notice? Well, I notice that we only for sure know the point 4, 7. And so I notice that it has been plotted on this coordinate grid and it's right there. Okay, so I do notice that they went that this goes over 4 and up 7, and then a point is plotted there. I also notice that we know the y-coordinate for one of the ordered pairs, and we also know the y-coordinate for the other ordered pair. And so I noticed that the other ordered pair is right below the ordered pair that we know, because we don't know for sure if that's where it's going to be, but we know right now to start, we know that the y-coordinates, if you subtract them, 7 minus 3, we know that they are 4 units apart. And so to start off, that should be our first step, is to figure out, do we know both x coordinates or do we know both y coordinates? And if we know the y coordinates, we can subtract them and figure out what the distance is between them. Remember, this is the y-axis. Y-axis goes vertically, so that's why this line is going vertically. Okay, if we had the two x coordinates, then the x-axis goes horizontally, and so our line would go horizontally. Okay, so that's our first step, is just drawing that first line. The next thing that I know is in the problem, it gave us the information that the points are going to be 5 units apart. Now, most likely they're going to be diagonally apart from each other, because in order for them to make a straight line, that means either the x coordinates have to be exactly the same or the y coordinates have to be exactly the same. And in this case, we know the y coordinates are not. And the x coordinates could be, but chances are they're not going to be. So what we're going to do is we're going to actually make some pretend lines, diagonal lines. We are going to make 2 diagonal lines, and we're going to say, and they got to be a little bit longer than 4, because we're going to say that they are 5 units apart. Okay, and we're going to make them equal, because we're trying to figure out what point, or what could the x coordinate be to satisfy that it is 5 units away from the ordered pair 4, 7. Okay, and once we make those 2 lines, this looks very similar to what we did with the Pythagorean theorem. Like if I connect whoa, that went all over the place. Let's go back. Let's try this again. It's kind of hard to make a straight line when you're only using, okay, that's going to be the best I can do. Now, if you look at this, it creates 2 triangles, and they are right triangles, and they are equal. So we really only have to look at one of them. And what we're trying to figure out is how far are the x coordinates apart from each other. And the only way to do that is to figure out, basically use the Pythagorean theorem. Because right now it looks like on this triangle, I know the hypotenuse and I know one of the legs. So I should be able to find the other leg. Okay, so let's do some work. So look at the following. Okay, so I just chose one of the triangles and I plugged in some numbers. So 4 is one of the legs. So 4 squared would be like a squared. Okay, plus b squared, we don't know what the other leg is, equals c squared, 5 squared. 4 squared is 16, 5 squared is 25. Now remember, we're trying to get b squared alone, so we got to subtract. 25 minus 16 is 9. And our last step always is to take the square root because we don't want b squared, we want b alone. So square root of 9 is 3. And remember, we're only looking at the positive side of the square root because this is distance. So that is telling us that the x-coordinates are 3 spaces away from the x-coordinate that we know already. So if we look at the x-coordinate that we know already, it's 4. And so 3 spaces away from there, well, we could go to the left of it or we could go to the right of it. So 3 spaces to the left on a number line would bring us to 1. So I could have an x-coordinate of 1 and the y-coordinate will remain the same as 3. Or if we go 3 spaces to the right, that would bring us to positive 7. So 7 and 3 remains the same. So there are 2 possible values that could be true to make this 5 units apart. One of the values is 1 and the other value is 7. So that's our information. Okay? So basically we took our given information, which was they gave us the ordered pair and then they gave us 5 units. That is the given information that they gave us. We took it and we created triangles from it. Okay? And then in the end, we found out that it was 3 spaces, both directions, 3 spaces, both directions, and that brought us to 1, 3 and 7, 3. Okay, and that's our ending information. Nice job. So look at this problem. What is different about this one? Exactly. This one, do you notice the x-coordinates are the ones that are given to us? And so that means x-coordinates, remember, go horizontally. So if I start at 2, positive 2, and I work my way to negative 6, that is 8 spaces away. So that's where that 8 came from. Then the information that was given to us was 10 units apart. So they're 10 units apart. So we drew a hypothetical diagonal line of 10. And then we use the Pythagorean theorem. So that means 8 squared, which is 64, plus b squared equals uh, equals 10 squared, which is 100. And if we subtract 10 minus 64, whoop, go back. 10 minus 64 is 36. And if we take the square root of that, that would get us to b is 6. And so that means that our points for the y, because that's what we're looking for, is a missing y coordinate. Let me put the square root on there. Is 6 units to the left and 6 units up and 6 units down. So if we look at the one that was given to us, negative 6, or negative 6, 2, if I go up 6 units, So if I start at 2 and I go up 6 units, that brings me to 8. If I start at 2 and I go down 6 units, then I'm at -4. And so that's where these ordered pairs came from. Okay, so let's look at some steps. Okay, so here's another problem, and I set this up with the steps. Okay, so step number 1, plot the given point. So here's the point that was given to me. So I plotted -1, 2. That's the first step. Then I drew a line, and my line depended on which coordinates I was given. If I was given the x coordinates, then I had to do a horizontal line. If I was given a y coordinates, I did a vertical line. Well, in this case, I have y coordinates. And so I did a vertical line from +2 down to -2. Okay? Then, and that was 4 units away from each other, so I put a 4. Next step, I drew diagonal lines. And remember, these are just, you're taking a guess about where it's going to land, because right now you don't know what your x coordinates are. And so I drew a diagonal line and I put a 5, and I made it a little bit longer because it should be longer than 4. So I made them equal, and then I put 5 on them. Then I used the Pythagorean theorem to find the third part of my triangle, or the other leg that's missing. And this is the work that I did down here. I found that the square root of 9 was 3, so that was my missing leg. And that's the distance that I'm looking for. And so now I could figure out what could P be just by going 3 units to the left and 3 units to the right. So if I go 3 units to the left, I am actually at -4 because I started at -1. So if I go 3 units, that would take me to -4. And if I go 3 units to the right, that would take me to +2. And if you notice, the lines that I drew before, they're not exactly right. I mean, I would have to actually, to make these actually true, I'd have to shorten it up to about right here. These pink lines should come down to about right here. It actually doesn't matter about the drawing part with the diagonals, as long as you can tell me what would the values be for P, okay? -4 and +2 would be my answers. What I would like you to do is try a problem out, okay? I want to see you draw out the triangles and see if you can figure out what could the possible values be for A, okay? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.